Today we are going through lesson 1-4, which is all about radicals. So again, we are exploring some of the foundations that we need to be able to do other things in Algebra 2 in this first unit. So we are going to start by talking about radicals in this lesson. So radicals is where we have a number multiplied by itself, and that's going to give us the radical number. So the number that we're taking the root of. For real numbers, the square root or any even root of a negative number is impossible because you can't multiply a real number by itself and get a negative, because a positive times a positive is positive and a negative times a negative is also positive. So when we're multiplying something by itself, we're always going to get a positive number. So it would not be possible to get a negative there. So therefore we can't take the even root of a negative number. So in words, when we say the square root of 121 is plus and minus 11, we have to get the positive and negative of that number. And in symbols, this diagram kind of shows what the nth root of x looks like. So we have our root here, the n there that this arrow is pointing to, that represents what's called the index. So it's the type of root that you are taking. And if there's no number there, then we assume that it's a square root, a second root. The number inside there is called the radicand. So the number we're taking the root of is called the radicand. And then that symbol denotes the principal root, which is the positive square root of a number. So those are kind of the key words that we need to know. All right. So some other things we need to know is that if we are taking the root of a positive number, so that would be any number greater than 0, if it's an even root, then that means we would get two real roots. We'd get a positive and a negative, like we did with 121. If it's an odd root of a positive number, then we would get one real answer. So like the cube root of 8 would just be 2. There's no other number we can multiply by itself 3 times to get that. So there's only one real root. If the number we're taking the root of is negative, it's less than 0, then that means we would have no real roots. Remember, we talked about we can't take an even root of a negative number. It's not possible. However, if it's an odd root, like the cube root of -8, we can still get one answer, because that would be -2. When we multiply a number by itself an odd number of times, then we can get an answer that's negative. And then if x is just 0, so if we're taking any root of 0, then we're always going to get one real root, and that root is going to be 0. So any root of 0 is 0, is essentially what that's saying. We also want to remember that a radical can be written as a power, so an exponent, with a fraction exponent. So we can rewrite the nth root of x to the m power as x to the m over n power. So we can rewrite a radical as a fraction exponent. So those are kind of some of the basics of radicals, some of the things we need to remember to solve some problems with it. So what we're going to do now is we are going to start practicing a little bit with these. So we're going to take the words, we're going to write this in the way that it's talking about, and then we are going to solve them. So this one says take the cube root, so cube means third root, of -64. So what that is saying is what number times itself 3 times is going to equal -64. So the first thing I know is that to get a negative answer, I have to have a negative number, so it's going to be negative, and then I have to think about what times itself 3 times would give me 64, and that would be 4. So -4 is the cube root of -64. B says find the fourth root of 625. So we've got the fourth root of 625. And when I take the fourth root of 625, I would get 25. Remember that when we take an even root of a positive number, we always get plus and minus. We get two real roots, so we want to make sure we include that. All right, letter C here says find the fourth root of 81. So again, I'm looking for what to the fourth power is 81. And again, because it's an even root of a positive number, we're going to get plus and minus. And then 3 is what multiplies by itself 4 times to get 81. All right, for D, it says rewrite the fourth root of 5 in exponential form. So it's asking us to rewrite this with an exponent that's a fraction. So I have 5 as my base, and then my power, or my exponent, is 1, since it's not written there, and my root is 4, so it'd be 5 to the 1/4 power. E is asking us to do that in reverse, so I know that 2 is my exponent, so I'm going to have 2 squared, and 3 is my root, so I'm taking a third root of 2 squared. If we wanted to simplify that, we could take the cube root of 4. That's not a nice number, it's a decimal, so we could just leave it as that to be exact. All right, let's look at some roots to kind of help us here. So we're going to fill out this table, and we're going to use it to help us break down some radicals. So if we have something that's not a perfect root, where it's just not a nice number, we can sometimes simplify it when we have the smallest possible number left under the radical sign. So let's go through these to kind of help us simplify some things here. So first, we're going to just take each number, we're going to square it. So 1 squared is 1, and cube it. 1 times 1 times 1, still 1. 2 squared is 4, 2 cubed is 8. 3 squared is 9, and 3 cubed is 27. And we're just going to keep going. 4 squared is 16, 4 cubed is 64. 5 squared is 25. 6 squared is 36, and 6 to the third power would be 216. 7 squared is 49, and 7 cubed is 343. 8 squared is 64, we've got that one, and then 8 cubed is 512. 9 squared is 81. 9 cubed is 729. 10 squared is 100, and 10 cubed is 1,000. 11 squared is 120, and 12 squared is 144. So we are going to use those numbers to, to help us break down some key things. So we are simplifying these non-perfect roots. So the steps here are to first determine the largest perfect square or cube or whatever root we're taking that divides into our root. So in this case, we have 72. So we want to figure out, and it's the square root, in my square root row here, what's the biggest number that I can evenly divide out of 72? So I know that 9 goes into it, but let's see if there's a bigger number. So 16 into 72. 25 into 72 does not go evenly. 36 goes in. So the largest perfect square that divides into 72 is 36. It goes in twice. So we're going to break down the radical into the square root of 36 times the square root of 2. Then we're going to take the square root of that perfect square I just divided out. So that's going to be 6. Just 6. Remember, we don't leave it inside the radical because the square root of 36 is just 6. And then we leave the root outside. So we have 6 root 2 is our final answer. So that's how we break down non-perfect roots. We take out any perfect root we can, the largest one we can, and we leave what's left over inside the radicand. So let's practice that a little bit here. I would encourage you here to pause the video and try these problems, splitting it apart using our work, and then come back and check your work. All right, so 48 I can break down into 16 times 3. So that would give me 4 root 3. 150, the largest that goes into that is 25 6 times. So that would be 5 root 6. 405 is a little bit trickier, but if we kind of guess and check there, I know that 81 goes into it 5 times. So that would be 9 root 5. 242, that's 121 times 2, so that would be 11 root 2. 900, I know 100 goes into it, but that would be 9 times, so that means it's actually a perfect root in itself because they both break down. And so 900, sorry, not 90, let's go back there. The square root of 9 is not 9. The square root of 9 is 3. So let's change that to a 3 and get 30. There we go. 30 times 30 is what gives me 900. All right, these next one are cube roots. So using that next row down, breaking up the cube root of 32, that breaks down into the cube root of 8 times 4. So the cube root of 8 is 2. And then the cube root of 4 we leave alone. Let's see, negative 432. Remember, we can take odd roots of negatives. So this would be the cube root of negative 216 times 2. And the cube root of negative 216 from my table is negative 6 cube root of 2. So we're going to leave that part in the radical. 1715, that is divisible by 343, which is one of our perfect cubes. And that would be times 5 to get up to a 1715. So when I simplify that, I get 7 cube root of 5. All right, a cube root of another negative. Let's see, 625 I can break apart into negative 125 times 5. And that would give me negative 5 cube root of 5. And lastly, we have 2187. That's the cube root of 729 times 3. So doing that one, 9 is that root, and we still have the cube root of 3. And then we have some fourth roots here. So fourth roots we didn't have in the table, but we can still kind of use our calculators to help us figure this out. The fourth root of 512, I can break that apart into the fourth root of 16 times 2. So if I'm not exactly sure how it works, but I know 16 is a perfect fourth root, then I can kind of help myself. The fourth root of 16 is 2, so I can do that twice and then be left with the fourth root of 2. So that would simplify to 4 fourth roots of 2. For number 4, 1875, same thing. I know this one can break down into the fourth root of 625, and that would be 3 times it goes in. So the fourth root of 625 is 25. No, it's 5. There we go. It's 5. And then the fourth root of 3. Right. Now, this one has a number outside already. We're going to square root, so again, pay attention to what kind of root you're taking here. But if I break apart, so I'm going to leave the 3 alone, and I break the square root of 28 into the square root of 4 times 7. That would be 3 times 2 times the square root of 7, which would give me 6 root 7. So we just loop that number out in front in with whatever you pull out from the radical. For this one, I have the cube root. 48 would be negative 8 times 6. So this would be 5 times negative 2 times the cube root of 6. So that'd be negative 10 cube root of 6. And then lastly for this one, breaking down the fourth root of 40,000. It's a big one. I've got the 2 out in front. And then I can break 10 or 40,000 into 10,000 times 4. So that would be 2 times 10, because the fourth root of 10,000. There we go. Fourth root of 10,000 is 10, and then leave the fourth root of 4 there. So that would be 20 fourth roots of 4. All right, so that is simplifying. The last thing that we're going to work on here is a little bit of operations with radicals. So what do I do if I have multiple radicals that I'm trying to combine as opposed to a single radical that I'm trying to simplify? So for this one, we're going to look at some rules and some examples and kind of see if we can figure this out. So when we have the product of radicals, remember product means multiplying. So you can see in our example here, we're multiplying a radical times a different radical and getting a simplified one. So the rule is basically that when I multiply two radicals that have the same index, so it can't be a cube root times a square root or a fourth root times a cube root. It has to be the same type of radical. I can combine those into one radical. Same thing works for the quotient. So we can split it apart into two radicals or combine it into one, depending on how we're trying to simplify. But when we're dividing any sort of radicals, so if I have A over B, I can split those apart into two separate radicals in order to help me simplify. When it comes to adding and subtracting, we kind of treat them like terms, if you will. So you can think of the roots as variables. So as long as I have the same type of radical, to be the same index and same radicand, I can't combine a square root of 3 with a square root of 5. Those aren't the same. But if I have the same radical, then I'm going to add the coefficients or subtract if needed. So let's say I have a square roots of x minus b square roots of x. So those square roots have to be the same. I could do a minus b and then put the square root of x in. So we can combine the coefficients that are out in front of it by adding or subtracting whatever the operation says and keeping the root the same. So we wouldn't add the square root of 6 and the square root of 6 in our example here. I would keep it as the square root of 6. I would just combine the coefficients. All right, and then the last thing we need to remember about radicals is to rationalize denominators. So we can't have a simplified answer if there's a radical in the denominator. So to get rid of that radical in the denominator, we multiply the whole thing by that radical over itself, so that we're essentially multiplying by 1. It's just a version of 1 that will help us get rid of this radical in the denominator. So that's how we rationalize the denominator to get a simplified answer. So when we are done, we need to check to make sure we're in simplified form. That means that our radicand is not a fraction. We can't have that in the denominator. There are no radicals in the denominator, and the smallest number possible is under the radical. So we've pulled out any perfect roots that we can. So let's do a few practice problems here. So for this first one, I'm multiplying. And remember, when we're multiplying, we can multiply the numbers out in front. And then we can multiply the roots together. So that would be 10 root 30. Then I would just need to check, can I pull any perfect squares out of 30? And in this case, I can't. So that is my final answer. All right, for the next one, very similar. We're going to multiply 2 times 7. We're going to multiply the square root of 45 times the square root of 2 and get the square root of 90. And then I can simplify that. So the 14 does not change, but the square root of 90 I can split into the square root of 9 times the square root of 10. So I've got 14 still out in front. The square root of 9 is 3, and then I still have the square root of 10. So when I simplify that, 14 times 3, that's 42 root 10. as my final answer. All right, this next one, I can see some division going on with radicals, so I need to combine those if I can. So I'm going to rewrite this as 2 times the square root of 15 over 5. So combining that fraction under one radical as opposed to separate ones. When I do that, I get 2 square roots of 3, and square root of 3 is simplified, so that would be my final answer. All right, now number 19 looks very similar, but I can't divide 49 by 2. It's not divisible by that. So on this one, instead, I'm going to simplify first. So the square root of 49 is 7, and the square root of 2 is not a nice number, so I'm going to leave it as 21 over the root 2. When I look at my simplification, remember I can't have that radical in the denominator, so I need to rationalize it by multiplying by that same radical in the numerator and the denominator. So I would get 21 root 2 over the square root of 4, which is 2. So that would be my simplified answer. All right, this next one, we are looking for some like terms here. So I see the square root of 3 and 12 square roots of 3. When I combine those, that means I have 13 square roots of 3. And then I also have a 5 minus 2, which is 3. And I can't combine those because one has a root and one doesn't, so that would be my final answer there. All right, last one here. I am distributing here. So 4 times 2 is 8 roots of 12. And then I also am multiplying here. So minus 4 root 27. And then I need to simplify these if possible. So I can simplify the square root of 12 into 4 times 3. And I can simplify the square root of 27 into 9 times 3. So that would give me, let's see, the square root of 4 is 2 times that 8 that's already there is 16 root 3. And the square root of 9 is 3 times 4 is 12 roots of 3. So now I've simplified it so that I can combine those, and I would get 4 roots 3. All right, those are your basics around radicals. We'll see you next time.